Welcome to another TouchDesigner tutorial. In this video, we're going to look at the technique called instance texturing. What that allows you to do is to generate instances in the usual way and then apply textures to each instance independently. Like most things, when we are talking about working with instancing geometry, it is both very flexible and can be scaled up to encompass a large number of instances. So it's a pretty cool and useful technique to have in your toolbox. Without further ado, we'll jump right into putting this together. So we're going to start off with a blank network, and we'll build the geometry portion of the project first. I'm going to begin with a rectangle SOP. And here I'm going to leave the scale at 1 by 1. I'll then attach a null to this operator in case we want to, say, swap out the geometry for something else. And then I'll right-click on the output of the null1 operator, head to the comp page, and grab a geometry comp, which will make the connection from the null to the geo automatically. So we've got that set up, and we might as well get the rest of our basic rendering pipeline while we're at it. I'm going to use a constant material in this case, because I don't really particularly care about having any shading or lighting or that sort of thing. I'll add a camera as well. And here I'm going to make a slight adjustment, which will come more into effect when we start instancing our geometry later on. I'm going to set the translate here to 2.5, which will pull us a little bit closer to what we have on screen. And then, of course, we need a render top as well. So we can see right away that we have not yet assigned this material, and that's why we're ending up with this black rectangle or square at the center of the screen. So I'll then grab the constant1 operator, drag it onto geo1, and in the pop-up that comes up, I'll hit parameter material. And there we go. We now have a single square at the center of our render. Now, since this is going to be a instance set of squares, the final result will also be square in its aspect ratio. So I think what I'll do in the render is to swap the output resolution for a square resolution. So I'm going to come to the common page and to the resolution parameter, and then I'll set that to 1024 by 1024. Next up, let's grab our SOPs that we'll use for creating our instances. So we're going to use a simple grid SOP. Although we'll be generating just 4 instances for this example, this will allow you to scale things up a bit and have a little bit more flexibility as you're putting this together and experimenting with it on your own. So within the grid SOP, I'm going to do a couple of things. I'm going to set the number of rows and columns to a value of 2 and 2. And then the other thing that I want to do is to activate the viewer in the bottom right-click in the operator viewer here, and then come to the display options parameter, which will bring up this little window. I want to display the point numbers, which we're going to use in a second to take a look at our instances. So we've got those added into our visible in the viewer, and I'll now add a null so that we can add in additional operators if we want to. I'm going to call this null POS for positions of our instances. I'll come next to the geometry comp again, and we'll head to the instance page where I'm going to turn on the instancing switch, and then we can drag the null POS operator onto the translate op parameter. Then I'll grab the P0, P1, and P2 channels for the translate X, Y, and Z respectively. Okay, so we can't really see a whole lot in our output at the moment because everything has the same constant white texture applied to it. And that is where we're going to start shifting gears into our instance texturing technique. So to do that, we're going to use a handy operator that we may or may not be familiar with, which is called the replicator comp. So this is available on the comp page, and we can find it here under the other category. As we can see from the description at the bottom, this allows you to create a node for every row of a table, creating nodes or quote unquote replicants and deleting them as the table changes. Now, although it is talking about using a table, we can actually just specify the number of copies or replicants of whatever operator we'd like via a parameter in this operator, and that's what we're going to do now. So what I'll do here is to, first of all, I need to create what they call a master operator, and this is going to be essentially the operator that we create replicants of. So I'm going to use a text top for this to create 4 different textures, which we'll use and apply to the instances that we're generating with our grid. So I'll grab the text top now, and then in the text top, I'm going to make a few changes and a couple of expressions and things like that. So for the text contents of the text top, I'm going to actually just pull in the digit from the name of that operator. So in the text parameter, I'm going to type in me.digits. And then I'll hit enter, which will just give us that as a string at first. We can then hit the text parameter title and then set the mode here to expression to actually evaluate that as a Python expression, which is now pulling in the digit from the operator's name. Then I'll come to the font page where I'm going to set the auto size font setting to auto fit always, so that it'll make that number a little bit more visible in this little canvas that we are working with here. I think I'll also set the bold switch to on so that, again, it's a little bit more visible. For my final adjustment in this operator, I'm going to come to the color page, and we're going to set up, using expressions, again, a background color that will shift as the digit at the end of the operator name shifts. So we'll come to the background color parameter. We'll click on the title of that parameter, and then in each of the channels here, at least for the green and the blue, that is, we're going to add in a little bit of a different expression than we saw last time. So I'm going to first type in some parentheses and then type in me.digits. We'll subtract 1 from that value. And then we want that whole expression that's in parentheses divided by 4. I'm going to copy that and paste it into the blue background color parameter. And then the last thing I need to make sure that I do here is to set this background alpha to a value of 1. Now I can use this as the master operator. So I can simply click on the replicator comp. I'll then drag the text1 operator onto the master operator parameter, and we are pretty much ready to go. Now it's still set up to look for a table to provide us with information about the replicants it'll be creating. However, if we come up to this replication method parameter, we can set this to by number instead. So what I'm going to be doing here is setting then the number of replicants to 4 and hitting enter. And we'll notice here that they have been replicated. However, they are currently placed over top of the instancing setup that we have previously. So fortunately, the replicator has some settings down here that allow us to adjust the position that these operators are going to be created at. And so we can start by adjusting this Y position. And we'll want to do that in the negative direction and probably by 10s to make things a little bit faster. So I'm just going to shift that down in space until it's below the replicator comp. And then we can take a look at what we've got. So we have, again, the 4 replicants, which we've defined by this number of replicants operator. We have the digit here that is being pulled in again from the operator name. So it is increasing as the digit in the operator name increases. And then also, again, the background color is increasing actually by a value of 0.25 each time that we increment our digit in our operator name by a value of 1. So those are going to be the textures that we work with. Now that we have these created, we can actually go back to our geocomp and start setting up our project to reference these textures. So I'm going to head to the geocomp. This is all going to be found on the instance 2 page. At the very bottom, you'll see we have this instance textures parameter. And this is going to allow us to specify using pattern matching, in this case, the operators in our network that we want to reference for the textures that we apply. So I'm going to take a look at their name, which is item with a digit at the end, and then I can use a wildcard after the name item. So item asterisk, I'll enter in for the instance textures, and that will grab all of the operators in the network that have, again, this first portion of their name as item, and then they can have anything after that initial portion called item. We'll see then if we head to the geo that now each one of these instances are textured. They are pulling in the top texture that we see down here, but they all have the same texture applied to them. So we'll notice that next up in this list of options is that we can provide a texture index operator and then a channel to pull from that operator. So essentially what we need to do is to set up an operator to tell our instancing setup which texture to pull for which particular instance. So a way to approach this that's really simple is to use a pattern chop, and that's what I'll do right now. So I'm going to grab that and add it into our project. The pattern chop, we're going to want to make sure that we synchronize the total length of this chop channel that we're generating to the number of instances. And the reason that we're doing that is because, as we'll remember from basic instancing, when we're thinking about instancing, we have one instance generated for each point within a SOP. And if we're talking about chops, we have one instance being generated for each sample within this chop channel. So right now we have 1,000 samples, meaning this would be set up to generate 1,000 instances, and thus we'd have a mismatch between the grid and the pattern. So what I'm going to do here is to reference the number of rows and number of columns in the grid SOP and use those to calculate the length of this pattern, because those two parameters are what control the total number of instances in this project. So let's write an expression to do this. I'm going to reference this grid operator by typing in op, open and close parentheses, single quotes, and then grid 1. I then want to grab the parameter called rows, so I'll type in .par, .rows, and then I want to multiply that by the parameter of the same operator called calls for the number of columns. So op, open and close parentheses, single quotes, grid 1, and then .par, .calls. By multiplying those two values together, we end up with the total number of points that are contained within this operator. Now, another approach here could be to simply grab the total number of points that this operator is generating. However, I just wanted to show you that you could do this in either way. So we've got this set up, and the next thing that we want to do here is to set the type to ramp. What that'll do is give us a nice clean ramp waveform, and this is going from 0 to 1 in the current configuration. So now that we've generated this ramp chop channel for our instance texture index, we're going to go ahead and connect it to the geometry comp so that we can take a look at some additional adjustments that we need to make. I'm going to add a null and call that null space index. We can also come to the pattern chop and set the channel name here to index, and then I will go ahead and click on the geo comp And we're going to use this null index operator as our texture index op. We then have to select an attribute here to use for the texture index, and we're going to select the index channel that we've set up. Now you'll notice that we have some changes in our output, but they are not quite what we're looking for yet. And the point that I want to make here is that the index parameter that we're using here, again, to define which texture is being applied to which instance, this is not a normalized 0 to 1 value, which is what we're actually generating over here on the left. To, say, assign texture, the texture with the number 4 down here, which is item 4, to, say, this first instance in the lower left, we would have to set the value in the chop channel to a value of 3 because this is 0 index based. And so basically what's happening here is because this is only going between 0 and 1, we're not able to assign any of those textures that need a value larger than 1 in order to be assigned to one of these instances. So to fix this issue, we can simply come to the pattern chop and we can set the to range here in the output. We can synchronize this to the number of replicants that we're creating. Now I'm doing that because, as I said, we kind of have decoupled the number of textures that we're generating from the number of instances that we're generating. And thus, we might want to have more instances, but reuse these textures as we're experimenting. So that's why we're not assigning it to the number of samples from the grid, and instead using the number of replicants from the replicator comp. So I'll click on the replicator comp. I'm going to then click and drag from the number of replicants operator, and you'll want to not hold for too long so that the value ladder comes up, but just click and then start dragging, bring that over to the pattern chop, and then I'm going to use this on the to range, the upper limit here, and click reference. So now we almost have this set up correctly, but remember that I said a moment ago that the chop channel here is 0 index based. And what that means is we need to subtract 1 from this upper limit to end up assigning the textures correctly. So I'm just going to add the -1 there to the expression and hit enter, and then we've got the textures correctly assigned to each one of the instances. Now, one of the things that you might be wondering is why has the number 1 texture been assigned to the lower left and the number 4 in the upper right? What is actually controlling the order of the textures that are being applied here? And that actually has to do with the point numbers that are assigned in this grid SOP. So as we can see here, the point number 0, which is the first point, is in the lower left. And that means that when we look at our index chop channel below, whatever the value is at this very first sample, that is going to correspond with whatever texture is assigned to this first point. So if I were to come to the pattern chop, for example, and turn on the reverse switch, you can see that now at this first index, we have a value of 3. And that's why we have the 4th texture being applied in that lower left corner. Now it's possible to use something like a sort SOP to change the ordering of these points if you, for some reason, want to, but it's also sometimes easier to, especially when you have a lot of points, to work with the chop channel and just selectively choose which texture you want to apply to that particular instance. So hopefully that helps clear things up a little bit as to how this functions. And I'm going to turn this reverse switch back off before we continue on. So now that we've got our basic effect complete, let's take a look at some other things that we can do here. Now, of course, we have available on the instance page the usual kind of rotation and scaling options that you may have seen elsewhere that could let us rotate these individual tiles however we'd like. Which is kind of cool, but I think what we'll focus on in this case is to instead think about the textures that we're applying and how we can actually manipulate the texture coordinates. So this is going to involve adding in an additional operator to our instancing setup, which is going to be another pattern chop. So I think the easiest way to do this really is just to take this first pattern chop that we have already created and copy and paste it below. We're going to have to make some changes here, however, and we'll start off on the channel page because we're going to need values, or channels rather, for the UV coordinates of our texture. So essentially what we're going to be doing here is sort of manipulating the position of the texture being applied to these rectangles and give those a little animation of sorts of their own. So on the pattern chop, I'm going to actually call these channel names Chan1 and Chan2 because we're going to be working with an additional operator, an optional additional operator that will change the names to those. And I want to make sure that we can sort of selectively turn that on and off. So we've got now 2 different channels. Next up, we're going to come back to the pattern page and set the type here to be a sine wave. And you'll notice now we have 2 identical channels, and we want to actually shift the second channel here a little bit so that it has a different phase from the first channel. And you know what might be helpful to do here actually is to connect this to our instancing setup so you can see the impact of what we're doing. So first, let's go ahead and add a null to the end, and we'll place it over here so we have room to work. I'm going to call this null, maybe text coord or something like that, because this is again going to control those texture coordinates. We can drag this into the texture coordinate operator. And then for the U channel, I want channel 1, and for the V channel, I want the second channel, channel 2. Now you'll notice that we've lost the numbers, but we've kept the colors. And that's because we've set the texture mode here to replace. If we then change that to transform, we've got our numbers back. So let's head back to the pattern chop for a moment. If we shift the phase using the phase step per channel of this second channel, let's have a look at what happens. You'll notice that we can effectively animate using this parameter if we like. But what this is going to allow us to do actually is really it's going to allow us to control the motion in a little bit more of an interesting way that we're going to apply. So again, to illustrate this, let's take a look at adding that motion. I'm going to animate the phase parameter here, which is effectively going to do this sort of back and forth type of translation for each one of these textures independently. I'm going to type in ABS time dot seconds and multiply that by 0.1. Now we've got that back and forth oscillating movement. Now, because the phase of these 2 channels is identical, this is really only going to be happening on like a 45-degree angle. But if we start to shift the phase of the second channel with this phase step per channel parameter, we can end up with something that is a little bit more circular. So for example, if I set this to 0.25 for the phase step per channel parameter, you can see now that these are moving in a circular sort of fashion. We can set this to 0.5 and end up again right back to where we were, but with things rotating at a 45-degree angle in the opposite direction. So let's leave it at this 0.25 setting, which gives us this kind of cool circular motion, and talk about some of the other things that we can modify here. So the reason that this is working and functioning this way is that the instance textures parameter has built-in extend modes for the UV coordinates of the texture, meaning that if these values that are coming in for the UV coordinates of that texture move beyond the default 0 to 1 range, these decide how it will deal with those situations. So we can change this behavior by setting the extend mode here to something like mirror instead. And once we do that, we'll see that we have, instead of just a replicated, repeated number in the right orientation, we now have numbers flipped in all different directions, which makes things potentially a little bit more chaotic, potentially a little more interesting. Just wanted to point out that that is an option that you are more than welcome to play around with. So this is pretty cool. We can also, of course, add in additional operators in between to modify how this behavior is functioning. And one of those is the phaser chop. So I'm going to add the phaser chop in now, which, as you can see from the description, does staggered time offset animation interpolation, which is actually something that looks pretty cool in this particular scenario. I'm going to add a switch chop after the phaser so that we can choose between these two approaches. And once I've got that placed into the network, I'm going to connect the phaser to the second input, or the to that multi-input connector second. And then I also want to provide a phase input for this input number 1, which is going to give us the correct number of samples and the correct number of channels. Another thing that I'm going to do here is to set the edge a little bit higher to 3.95. All right, cool. So now if we come back to the switch and we swap this index up to a value of 1, you can see that we end up with a very different kind of animation, which is a little bit more stiff and robotic, but also kind of interesting in its own way, as the numbers sort of appear to fall and slot into place before moving on in their path of travel. So these are just a couple of ideas for how you can start to play around with texture instancing and push it beyond the kind of static application of textures to instances. But hopefully all of this has gotten you excited for the possibilities of this technique, even if it is just to add textures to instances. So with that said, hope you've enjoyed putting this together. Looking forward to seeing you in the next video here on this channel. And if you like what you've seen here, make sure to like and subscribe to my YouTube channel, and you can follow me on Instagram at Jack Delora. Thanks for watching.